Okay, now we're going to start Lesson 8, which is what we call the shortcut method of derivatives. So what we're going to do for the first two examples, I want to remind you of the definition of derivative. And then we're going to go in and I'm going to show you some some shorter ways to take the derivative. And some of you may already know this, and I didn't remind you that if you knew this in the last video, you weren't allowed to use these. Which I will state when I go through the discussion board and stuff. So first off, let's take the derivative of the first two examples using the definition so that we can see some patterns. So if we take the derivative of the first function, the linear function, using the definition, so the limit as h goes to 0 of f of x plus h minus f of x all over h, then what we get is the limit as h goes to 0 of 5 times x plus h minus 4 minus 5x minus 4 all over h. Then we get that f prime of x equals the limit as h goes to 0 of 5x plus 5h minus 4 minus 5x plus 4, so our x go away, and we're left with the limit as h goes to 0 of 5h over h. H's cancel, and if we take the limit, then we're left with 5. So our derivative is simply our slope. So the derivative of a line is the slope. All right? So it's one down. It's one exponent down. So now let's look at our quadratic. So if we have g prime of x, that equals the limit as h goes to 0 of g of x plus h minus g of x all over h, which is the limit as h goes to 0 of x plus h squared minus 3 times x plus h plus 4 minus parentheses x squared plus 3x plus 4 all over h. So g prime of x equals the limit as h goes to 0 of x squared plus 2xh plus h squared minus 3x minus 3h plus 4 minus x squared, because this was minus x squared plus 3x plus 4. Actually, that should have been a minus. Plus 3x minus 4 all over h. So g prime of x equals the limit as h goes to 0. So we're going to cancel out the x squared. So all of those go away. Now I'm going to factor out an h. So I have h is 2x plus h minus 3 all over h. So my h's cancel. This h is going to go to 0. So what I'm left with is 2x minus 3. So notice that when I took the derivative of a line, I had the slope. When I take the derivative of a quadratic, I get a line. So notice that as I take the derivative of each of these functions, they go down in power. That leads us to the fact of the power rule. So the power rule says that if I take the derivative of something to the nth power, that I bring my n down and I take n minus 1. The derivative of a constant, so I want you to see this. So I like to write this as that's a constant times x to the n. So the derivative, so if I take this derivative using the power rule, that's the constant times 0 times x to the 0 minus 1. Okay, Well, anything times 0 is 0. So that whole thing becomes 0. Okay? If I have a constant times, and see, if I have a constant times the function, then it's the constant times the derivative of the function. I can multiply derivatives to each one. I don't have to, I can take the derivative of each function. I don't have to do that. So next thing you need to know is that the derivative of the distance function, so this is the distance, the derivative of distance is velocity. The derivative of velocity is acceleration. And the way I take the derivative to get acceleration is it's the derivative of the derivative. Now, the next thing you need to know is that all of these mean derivative. So f prime, y prime, and dy dx. Okay? So now let's just start taking derivatives. Okay? And that's all we're going to do for the rest of this is use the shortcut method until we get used to it. Now let me say this. The more you take derivatives, the more you'll get used to it. All right? So, for the first one, f prime of x equals 5. 5 is a tag along. If you've ever had a puppy, and you know that I have a puppy because he sits at my feet when I lecture, when I make these videos, they will follow you around everywhere. My kids do the same thing. So whenever I go anywhere, I'm like, I have a tail. So the constant is like a tail. It follows you around. So this is the 5 times, I bring the 4 down, so it's x to the 4 minus 1. So 5 times 4 is 20x cubed. Now, if you can, you are more than welcome to go straight to here. All right? So that's it. That's all you do. Now, for the second one, I need to rewrite the function first before I can take the derivative. Now, when I rewrite this, I'm going to rewrite this as x to the first plus 4x to the negative 1 plus 1. Now, you have to write this. You do not have to do this. So this is do not have to do. This is a must do. Okay? So now to find y prime, I do minus 1 times 1 minus 1 plus 4 times negative 1x to the minus 1 minus 1, and so that's the second term, plus, and this is x to the 0, right? And you do not have to do this one. So this is 1 times 0x to the 0 minus 1. So this first term becomes, so y prime, now I'm going to simplify. So this becomes y prime equals negative 1x to the 0 plus minus 4x to the negative 2 plus 0. Okay, now I'm going to simplify again. So y prime, and this is going to be my final answer, is minus 1 minus 4 over x squared, and that goes away. So this is what I'm expecting your final answer to be. Okay? Because I started out with x in the denominator, I must end with x in the denominator. Okay? Now, let's go on to the next one. F prime of x equals 9 times 0.5 x to the 0.5 minus 1 plus 7 times negative 0.5 x to the negative 0.5 minus 1. So f prime of x equals 4.5 x to the negative 0.5 minus 3.5x to the negative 1.5. And that's your final answer. Okay? Now, first, you have to rewrite your original question. So this is y equals 3x to the negative 2 plus x to the negative 3. So dy dx equals 3 times negative 2 is negative 6x to the negative 3, because minus 2 minus 1 is negative 3, minus 3x to the negative 4, minus 3 minus 1 is negative 4. So dy dx equals negative 6 over x cubed minus 3 over x to the 4th. All right? Here you need to distribute your x through the parentheses. So this is x cubed minus 7. So now s prime of x is 3x squared, and the derivative of 7 is 0. Because the derivative of a constant is 0, or I could say that's 7 to the 0, so pull down the 7, pull down the 0, and that's it. All right. Now, I need to simplify this as 4x over x plus 3x squared over x. So that's 4 plus 3x. So t prime of x is simply 3, because the derivative of a linear is just the slope. All right. Now, the first thing I need to do is to find my point. So first is to find my point. So that is s of 4. So that's the square root of 4 plus 3 over the square root of 4. So that's 2 plus 3 halves. So that's 4 halves plus 3 halves is 7 halves. So I have the point 4. So I have the point 4 7/2. Second, I need to find the derivative. So s of x equals x to the 1/2 plus 3x to the negative 1/2. So then, and that symbol means then, s prime of x equals 1/2 x to the negative 1/2 minus 3/2 x to the negative 3/2. So now I need to find my slope, which is s prime of 4. So that is 1 over 2 times the square root of 2 minus 3 over 2, the square root of 2 cubed. So, and that shouldn't be 2. That should be 4, and that should be 4. I was taking the square root at the same time I was writing it. So that is 1 over 2 times 2 minus 3 over 2 times 2 cubed. So my slope equals 1/4 minus 3 over 2 times 8. So this is going to be 16. So that's going to be 4 over 16 minus 3 over 16. So that equals 1/16 is my slope. So 4, I have a slope of 1/16, the point 4 7/2, and y equals mx plus b. And I didn't leave myself a whole lot of room. All right. So doing that, I get that I have 7/2 equals 1/16 times 4 plus b. So that gives me 7/2 equals 1/4 plus b. So then I get 14/4 minus 1/4 equals b. So 13/4 equals b. So my tangent line is y equals 1/16 x plus 13/4. Okay? Now I want to find the points where the tangent line is horizontal. So a horizontal slope means my slope is 0. So that means I need to find the derivative. So f prime of x equals 3x minus 8, 3x squared minus 8x. And I need to find where that equals 0. So I need to find where 0 equals 3x squared minus 8x. So 0 equals x times 3x minus 8. So x equals 0 and 8/3. So the tangent line is horizontal when x equals 0 and x equals 8/3. Okay, give you another chance to look at that. So next, we're talking about velocity. So, first thing I want to do is I've given you the distance formula or the altitude in feet or the position formula. And so first I want you to tell me the velocity. So velocity is the derivative of the distance. So I need to find v of t, which equals s prime of t, which is f prime of t, which is negative 6t squared plus 224t plus 640. And t is going to be greater than or equal to 0. Okay. Next, I want to calculate when the velocity, so I want to calculate v of 0, and I want to calculate v of 60. And so that's just plugging and chugging. So I'm putting them into, so negative 6 times 0 plus 224 times 0 plus 640 equals 640. And then I put negative 6 times 60 squared plus 224 times 60 plus 640 equals 13,720. And both of these should be feet per second. And again, make sure that you write them up in a complete sentence. So the rocket's velocity the rocket's velocity at t equal to 0 is 640 feet per second, and at 60 seconds is 13,720 feet per second. Okay? And the reason I like complete sentences is it tells me an understanding of what the question is asking. So the next question says, using the results from part B, find the maximum altitude obtained from the rocket's height. And this really should be from part A. So velocity equals 0. So we want to set 0 equal to -6 t squared plus 224t plus 640. Now I use the quadratic formula to solve this. So t equals -b plus or minus the square root of b squared minus 4ac all over 2a. And what I found was -224 plus or minus the square plus or minus 256, because it was, you could take the square root of that number, over -12, and so I came up with the two answers of -8/3 and 40. So it was actually factorable. So what that tells me is that it had a maximum altitude at, so the maximum max altitude occurred, that should be an E, at 40 seconds, because this can't happen because t is greater than or equal to 0, and this is in seconds. At 40 seconds.